Good afternoon, everybody. Thank you very much for being here. Thank you very much for inviting me to speak on this occasion. Big data, is it just a hype we are currently going through? Is there a real opportunity to approach learning difficulties differently? In our view, it's a real opportunity. I will talk about that for a start. Then we'll discuss an experiment we're currently running, which we've called literacy analysis. And we'll close with a few learnings we have in this field of literacy, difficulty, and big data. Let me first make a clear distinction. A lot of data doesn't mean big data. Currently, we collect a lot of data in education. Already the previous speaker referred to the number of tests we do. Big data is a different thing. That's typically described by the 3 V's, which means high volume of data, high velocity, so high speed with which new data is being generated, and a high variety, diversity of data that are being gathered. Why are we currently seeing the emergence of big data in education? That is because new entrants actually enter the educational market. Whether it is providers like Snappet who offer quasi-traditional education at the core of school, or whether it is Taalzee or Schoola who offer additional games for children to learn spelling and language. Whether people like these developments or not, it's a fact that these entrants rapidly get into the market, not just in the Netherlands, but actually many Western European countries. And this is going really quickly. In 2012, there were about 2% of the Dutch schools who were actually using iPads or similar tablets at the core of education. This year it's about 10%. Next year, about 1 in every 4 schools is expected to use iPads. It doesn't mean they use it for everything, but it means they will have some of the classes at the core use tablets for their education. And perhaps in 2015, it's hard to predict, but it will be over 50%. So what data will be gathered by this tablet interaction? First of all, it's exercise data. So let's take an example of spelling. Is an exercise correct or false? What were the previous attempts when the child is making a false question? What's the response time? Did he self-correct himself first? And secondly, there's indirect data. So data you can defer from the previous category. Is it the learning rate? Is it a quick learner, a slow learner? What are error patterns? And how does a child compare to a norm? I think that's a much debated issue, because as soon as you start setting norms, what do you compare the child to? To himself a month ago, to that class, to a peer group, however you define that. So that's the type of data we start to gather now. And that's only the beginning. As soon as other sensors get into tablets, such as eye tracking, you start to assess much different data that will even increase the velocity, the variety, and the speed. Alright, how big is big? If you use 1 to 4 hours per day per student a tablet, you can imagine that this gets into millions of exercises within these systems that are being gathered. Just to give you an illustration, the experiment by the UvA partly, which is Oefenweb, that use Taalzee, they gather more than 1 million exercises every week. So you can imagine the numbers that are being gathered here. Is this a good or a bad thing? I mean, there's a lot of discussion. Should we allow computers in education the way we do? Much can be said pro, much can be said against it. And I think those are valid discussions. But for this purpose of this presentation, we just want to say, all right, tablets are going to be there. Let's actually start using it, but do that responsibly. Why is big data relevant? In essence, it's not necessarily for the data itself, but it's for the decision-making that you can support using this data. Any decision-making process has a sort of standard cycle. You start with collecting data, then you start to analyze those data. Third, you start to generate insights, i.e. interpreting the data. And fourth, you enable action, you take an action. Well, this cycle is a way of representing a decision-making cycle. And every decision-making process is as solid as you are able to take all these 4 different steps. If you have more data, you can make more analyses. If you have the data together, you can actually do those analyses. If you can compare them, the third step, to previous data, you can have much richer insights on how a child is developing. And if you're able to show that in a very clear manner to the user, you can enable proper actions. So the problem, if you so want, of big data is solve problems through better decisions at lower cost. Yes, education in a lot of ways is also a market, so it's relevant whether it's a cheap or an expensive analysis you're doing. I got involved in this project when I was studying for 2 years in London and in Boston at MIT, where the students were deliberately asked to work together between people with a more business background and people with a more science background. So often jokingly we said we have the blah blah people work with the bleep bleep people, and they together can actually change things that might increase innovation in education. So when I came back to Holland about a year ago, I brought together my own team of blah blah and bleep bleep, if you so want. This is a group of one child psychologist who's actually here. She works with children and children with learning difficulties. One person who understands mathematics very well, who does all the big data analysis. Another artificial intelligence person, a computer scientist, and a person who understands the interaction between man and machine very well. Because we know technology often is great on paper, but it also has to work, so you have to have someone who understands that interaction problem. And we baptized it Leeruniek, because every child learns in a unique way. We're supported by the Dyslexia Foundation Fund, also known as Stichting Dyslexiefonds, and we've been working with the University of Amsterdam Artificial Intelligence Department, and occasionally also with the Pedagogy Department. Alright, what did we do? We tried an experiment over the past couple of months. We called it literacy analysis. Any big data exercise roughly takes 5 steps. To start with, you have to have a problem you try and solve. You have to understand, secondly, the decision makers. Thirdly, the key questions, the key decisions that decision maker is making. Fourth, you have to understand what insights does this person need to make a proper decision. And only then you get to the data and start looking for the right data to support the insights. So let's start with the problem. What's the problem to solve? It's not a small problem. 10 to 20% of our pupils leave elementary school as functionally illiterate. And it's often defined as having a backlog of 2 years or more at the age of 12. 10% average in the Netherlands, 20% in bigger cities such as Amsterdam. This is arguably quite a challenge that we have as a society. The assist situation is at the left side. We have about 80 to 90% of the children leave as fluent readers, and 10 to 20% as not so fluent readers. And the small group, 4%, typically of those is what we call dyslexic, who has a severe form of dyslexia. Don't get me wrong, there's also people who end up being fluent readers and nonetheless are dyslexic. But for simplicity reasons, we represent it this way. So our objective is to bring down certainly the orange region to a much smaller percentage, call it 1 or 2%. The people who not necessarily have a reason to find it difficult to read and spell fluently, but nonetheless do in our current system. Well, we know the dynamics. If you look at the downward spiral, often in grade 2 and 4, which is Dutch for 2 and 4, there's small gaps. The child gets demotivated and frustrated halfway the elementary school. And if this is not addressed properly, you get to that backlog. So you get to the backlog at the age of 12. Somehow we have to try and stop that downward spiral. Well, also as per the previous presentation, actually we have a very solid methodological approach here, which we call the protocol leesproblemen in dyslexie, that tells schools what to do at what stage and how to intervene with different children. So, and this is not the case in many countries, so already we are very well organized here. But still we have the challenge of the 10 to 20% of non-fluent readers. So our experiment that we defined is, alright, let's build a dashboard that can support the observance, so the actual realization of the protocol we just referred to. Problem. Second step, who are the decision makers? Well, there's actually many of them. There's the special needs coordinators, IB'ers, and there is teachers themselves, there's people in school management and external experts. We tried to talk to quite a few of them. We've been doing interviews in the past 6 months with all different stakeholders, with schools. We interviewed 20 schools. We talked to many literacy experts from different institutes here in the Netherlands and in the UK. We've been talking to many parents, to academics in the Netherlands, the UK and Belgium, and to policymakers. And let me just pause at the academic side. Yes, we did talk to people with a background in pedagogy, but we also talked to people with background in psychology. But most conversations essentially we've had with people from computer science background, artificial intelligence background, and cognitive science background. Because those are the people who know how to work with big data. Not necessarily they're an expert in education, but they understand the power and also the pitfalls of big data. Well, it's difficult to summarize all of these conversations, but a few points really strike me look back in those conversations. Tests are very time consuming. There's a lot of administrative work that people complain about. There's not so much data about the root cause of a problem for people. Yes, people know which child is lagging, but it's difficult to understand why. Fourthly, yes, there's many tests. Yes, we have great test results, but actually interpreting them, using them, is not as easy. And fifth point, specific intervention often starts quite late. And let me point at this fourth point specifically. The usage of test results is also very important at the school level. And I'm aware that most of the audience here do analyze tests for their living. So they know basic analytics and basic statistics. But not necessarily school people are used to that or are educated for that. And also they have to understand test results. So, building this dashboard, we had 3 major points in mind, 3 objectives. First, we want to be data-driven, which has to be dynamic data that's generated every day, real-time data, and generating fine-grained insights on a detailed level. Secondly, we want to improve the well-being of children, because testing can be quite a burden on a child. And we want to intervene earlier, because the earlier you intervene, the less this sort of learning problem also turns into a behavioral problem or a social-emotional problem. And thirdly, we want to save time and administration time. Third point, key decisions. Many decisions have to be made, so I can't spend too much time on all of them. But I think, also borrowing from the slide we just saw previously, is that at what level should we intervene with a child? At level 2, which is care, extra care in the class, or at level 3, which is a much more specific intervention at school, but often outside the class. And the decision makers here are typically special needs coordinators and zorgteam members. Right, for those decisions, you go through the usual circle, and we hope that each of the steps we can improve slightly. How do we do that? We're building a dashboard with an overview of a class. This is obviously a draft one with only Alice Smith in there. You can have it on your tablet, on your computer, or on an iPhone. Then subsequently you can zoom into one of those children to understand the more detail of where the child is at its learning process. That brings us to the insights you actually need to make those decisions. Again, this is a markup very high level, so this is to give you an idea of the different type of, if you someone meters you want to understand of a child. Think of it as the different outcomes of different tests you're currently doing, both Brus or Claypole or B-Dictate, and name a few other tests, feed into one profile of a child that then gives you a much richer idea of where the child stands on his or her development. And one of them that we found that people often do in schools is an error analysis. What type of spelling errors is the pupil making? And out of all these meters we like to make, we've in the past couple of weeks succeeded in actually making the first one work, which is this error analysis. At what level is the child struggling? And more specifically, what learning objective does he or she not master fully? Building such a analysis tool, just one of those elements, for example the error analysis, requires you to build a prototype meter first. It's ugly, it doesn't look intuitive to any user. Secondly, you have to test whether it does what it promises. Thirdly, you have to test the interaction with users, and then it has to have a design that's actually user-friendly. And fourthly, you have to get into using a pilot in real situations so people can see whether this is actually usable. We are, as you see, in the very beginning, and we have built this first prototype and now are getting into the test phase. Alright, what does it mean? And again, this is ugly and just for our usage. What we do in practice is have the right answer of a word, which is called melkpannetje, and then this is typically an exercise that the child is making in school. So obviously the child doesn't see how you spell melkpannetje, but he gets a question and the machine knows what's the correct spelling. So this is the correct spelling. The second step is, what does the child write? He writes melkpannetje. So he's switching two consonants and then he's eliminating one of the ends that we should have in Dutch. This is a very typical mistake, but the different, actually two mistakes may mean different things. Our analysis tool that interprets what type of mistake is this actually. So the first one, the red one, represents, and actually we're not there yet, it should be read 2 times, it represents sort of a change of consonants. He or she may be dyslexic, maybe he's just sloppy. The second one represents perhaps different things. One of them is that he hasn't fully understood that 2 consonants in Dutch are needed in this case rather than 1 consonant. The very beginning of an error analysis tool that will feed into this overall dashboard. So just bear in mind, this is not a test. This is done automatically. So as a child is making spelling exercises every day, every week, all these errors come in the machine and slowly we get more information on that child. The insights you get from this can be, at what level does a pupil make most errors? So where should I intervene, in school or later on outside school? Secondly, where is he or she in his development? But more specifically here, how did he develop over the past couple of weeks? So it's not a snapshot when you did this one test. No, it shows you day by day or week by week how improvement is made or is actually not made. And thirdly, you get to a much more fine-grained understanding of where the child is having problems. The fifth point, I'll skip briefly, basically it tells what data did we look at. For this exercise, we looked at 1.5 million spelling exercises, and we extracted from that about 100,000 spelling errors that we interpret for this analysis. Alright, what have we learned so far? To be honest, this hasn't been an easy thing. We're learning on the go, thanks to many advisors who sort of think along to help us understand the complexities for the technical people who don't have an education background, but also for the education people who do not necessarily understand the technology. So you have to continuously talk to one another to make progress. First of all, the objectives we set ourselves, the 3 we mentioned earlier, are not easy: to be data-driven, improve well-being, save time and administration. But actually they seem to be feasible. Not this year, but perhaps in 1 or 2 years. Things we also figured out, and you might recognize these from the sort of popular press. Some topics are really important to address and it's not easy to address them. For example, what's the interaction between this dashboard and existing systems? How does it talk to Parnassus, for example? Or how does it talk to systems that you might use for your your electronic patient file? And thirdly, I guess the big element in the room is privacy. It's great to have a lot of data on specific children, but it's also very sensitive data. So how to go about that? So we have done analysis on purely anonymized data, but at some point you want to be able to talk to individual children, so you have to get permission from the parents to use that data. Anyway, long, complex story, but it's a topic that will have to be addressed, otherwise this is not going to fly, or it's going to cause a lot of potential problems and risks for children, which is something we wouldn't want. 3 learnings, finally. Technology should not take, but enable decision making. As soon as this fantastic algorithm that's behind here is going to make decisions, you lose ownership as a teacher or as a specialist. So yes, you can do analysis, but you always have to present the analysis in such a way that this person can actually decide what's right for this kid and what's not. Not the least because much information cannot be measured, so you have to add these sort of contextual, more qualitative information before you make a decision based on essentially numbers. And for that to be workable, it has to be a user-friendly tool that is intuitive to use. Secondly, you only get there, I already alluded to this earlier, if you take a multidisciplinary approach. So break down those silos. And I think here is something that the Rudolf Berlin Institute is really starting to do well, namely let practice and reality of schools talk to the scientists. Even though, ironically, we have this lovely wall here between the practical people and the more scientific people there. But I think this is a great start. And I would almost challenge the Institute also a little bit. If this is not being done with other silos, and I'm talking to those technology people, it's not easy to make as sensible and therefore responsible innovations as if we really work with technical people. And that leads to my third point, namely, technology is entering the market at a massive speed. Every year, well, we saw the numbers before, new entrants come to the market. And some of them are really well thought through. Actually, the examples I give here, I think, are done by real professional people. But it also brings in different players that answer different sort of incentives. If educators don't actively seek to work with these people, and again, great people, great entrepreneurs, you may risk of getting innovations in the classroom you actually don't want to have in the classroom. Specifically when it comes to testing children on anything you can test them on, and the topic of privacy is sensitive. So if educators don't take clear responsibility, and in my view initiative, it may be difficult to sort of return the clock and get more grasps on what we do in the classrooms. Leeruniek is trying to do this. We are pioneering. We are making mistakes. We thank everyone who's working with us to make those mistakes with us and hopefully prevent us from doing it. And we are hiring people. So any questions and other applications are welcome. Thank you very much.